What is up, guys? How's it going? So, today we're going to pick up where we left off with parsing class declarations. So, we're going to go back to parsing a class block. Now, I reviewed this before I started recording, and it looks like pretty much almost everything in here is a rabbit hole, meaning that it's going to split off into a bunch of episodes. So, it's not going to be easy for me to do a straight cut and clear video on how do you do this or how do you do that. From this point on, it's probably just going to be a bunch of various videos that talk about various things, and hopefully we can eventually get back to the core. So what I mean by that is so the next thing I'm going to show you guys is going to be how to parse a interface declaration. Um, but if we go in here and it says parse like an interface block, so if we ignore all of this code, we go into interface block, it has various different things in here to parse an interface. And when it comes to interfaces, the formatting is completely different. So I'm going to start to just create a bunch of short videos that explain basically the specific topic for what we're processing that day. So I hope that makes sense. If you guys have any questions or anything, just put them in the comment section below if maybe I skipped over something or whatever. So the first thing we're going to need to do for parsing an interface declaration is we're going to have our check here, our usual check where we just check to see if the token is equal to an interface. Once we do that, once we have confirmed the current token says interface, here I'm going to actually go here and put in the code interface, and I'm going to go back to the parser. So that's what we're going to be parsing. So the first thing you want to do is you're going to want to create a branch called interface declaration. And I'm going to go here really quick and copy the same code that was used in parse class declaration and put that into parse interface declaration. So once we do that, you want to have your access types. You want to add all of your access types. We saw how we did that in parsing a class declaration. Once you add your access types, then you want to free up your access types. You want to free up the list. And then you want to expect an identifier. So the identifier is going to be the name, right? So we've already processed this information. Now we want to process the name of our interface. Once we do that, there's going to be a couple rules for interfaces. So here are going to be the rules for interfaces. The idea is that an interface can come in a few forms. So you could have a regular interface where you have I don't know, a function or whatever. Then you can have a generic interface. You could say, you can put this and say type T, and then I don't know, have a define do work function, which returns a type of T. So this basically represents a generic interface, and the return type of do work is derived from T, which is specified here. Another form an interface can take is it can use polymorphism, which I think is the right word. Correct me if I'm wrong, but you can basically inherit other interfaces. So you can have a base, some other interface. So we have some other interface here, and we're including it as a base class. Now, because this is an interface, we don't want the user to be able to do something like this. So we don't want the user to say iFace1, iFace2, and whatever, right? So typically when you have a class, this is perfectly legal because when you have a class, you can have a base class and then you can also have interfaces. But it doesn't make sense for an interface to implement other interfaces. So we don't want the user to be able to do that. So we will only allow them to have base interfaces so that when whatever class inherits this interface, it must implement all the functions in this class here, as well as any subsequent functions in this class and beyond. So if we go back up to our parser, we can kind of see how I did that. So, I mean, we've already seen this code before. It's literally a copy paste. It's just if we had the less than symbol, say it's a generic interface instead of an interface declaration, that's important. And then we just do things like we normally do. So we expect the less than symbol, we expect an identifier list, and then we expect the right hand symbol. Otherwise, if we have a base, then this is pretty straightforward. You just say, all right, we have a base, expect the token base, and parse a reference pointer. And that's going to handle processing this. So you could even do something like this where you could say some interface of type T. Let's say your base class interface that you're trying to implement or inherit in this interface is also a generic class. So you can like force, or you can put the type of this into there, or you could, put whatever type you want. It doesn't matter. The compiler will figure out what it needs to do. And of course, I will show you guys how to do that in a little bit later on. But yeah, our parse reference pointer function will handle all this information and processing. So you can do all that. Also, another thing I want to note, so when you're writing your compiler, you want to be extremely careful with how you are processing things. One thing that you're going to see, or pattern you're going to see when I'm developing this language and showing you guys how I've developed it, is you're going to notice that I do reuse a lot of code. Like, I mean, all of this is like a copy paste from parsing a class declaration. I just removed the part where you can process interfaces and you can add them to the class. But you want to just be careful. So in here, I have a reference pointer. Um, and here's going to be an example of why you want to be careful with how you reuse your functions. So as you guys know, I have a concept called utype. So I'm going to search for parse utype. If I do a search for parse utype, that's going to take me to this function. Now, there's a very important reason why in the interface block I'm not using parse utype here instead of reference pointer, because utypes, if you remember, they can parse, this. So utype is basically any type in the actual language. So utypes can process actual native types. It can process, I don't know, some class, array, right? And if I were to use parse utype in this case, I would have to do a ton of more work to figure out what actually am I dealing with. Like, is the base class a native type? Well, then obviously I'm going to have to give an error, right? Or if we have a base class, has the user put this bracket sign after it? Is that legal? Well, obviously you can't have an array of a base class. Doesn't make any sense. So then we'd have to give an error for that. So because I'm using parse reference pointer, it's strictly limiting what I'm processing to only identifiers. So I know it can only be like some class dot inner class dot, some other class, and they're all nested. And then I can even have, types in the middle of that, and let's say this one is another type here. So you get the point, right? But I'm limiting the amount of information that I'm processing, so that way I don't have to do a ton of work on the compiler side, on the backend side when I'm actually processing the information. So just keep that in mind. And also, if we do a search for parse utype, we can see here that parse utype is a type identifier, and of course it supports the brackets to denote it's an array, but it does parse a reference pointer. So it tries to figure out, all right, is it a native type? Is it a function pointer? Okay, if it's not, then it's a reference pointer. So I just jump the gun completely and just say only parse a reference pointer, so that I know that the base class is in fact just a string of identifiers and I can process it very easily. Going back, if I go back to parsing an interface, so once you do that, once you parse your base class, then you're good to go. Create a parse interface block function. Once you do that, then you're going to want to create a AST block. Now remember, I use this same AST for anytime there's a block in my language, because for the most part, you can kind of expect to process or call the same function for processing all these blocks. Because the way that it's going to work is, although interfaces have a limited scope, like you can say do work and you can specify that this is a delegate function, but you can't put function implementations in here. I'm going to have code at the parser level to check to see if there's any function implementations in here, or I don't know, if there's like a variable declaration. Can't have variable declarations in an interface as well. So like if we had something called num. So all of those checks are going to be done at the compiler level, so at the parser level. So it would be completely safe to just reuse the same parse block function on the back end and just parse whatever ASTs it's provided. So that's kind of why I use the same AST block. I think I mentioned it before, but yeah. So once you do that, then you want to, of course, expect a left curly brace. And as per my last video, I mean, it's literally going to be the exact same logic. You guys have already seen it in my last video. how I process brackets, and how I process class blocks. So we literally just create the same brackets variable. It's the same exact while loop and the same code that's in the parse class block. So you check your error limits to make sure we haven't gone over 1,000 errors or whatever the limit is. Then you handle your access declarations. And then ignoring all of this stuff, if you go straight to the bottom, literally I have the exact same end of file code, the exact same right curly code, and the exact same left curly code, as well as the same, catch-all code. So this is the case where if we don't know what the heck's going on, we're just going to call the parse all function, and that's going to handle that. So at this point, I would say definitely just copy and paste the code that you guys have probably written if you guys are following along from yesterday's video. And you can just paste that inside of this function here as well. Definitely add parse interface declaration. I don't know where it is, but add the parse interface declaration to the parse all function, because that's a new AST that you're able to process. So once we do all that, that's kind of our initial setup. Also, of course, while we're in the while loop, we want to free up our access types every time we loop in our while loop. And we also want to, and the reason why I do this, by the way, is I just want to make sure that if we have access types, maybe there was some error or something, and we didn't consume them, like for instance, init declarations can't have access types. Well, if we process them, we just want to free them up. It's not going to do anything if it's empty, so, but yeah, I just want to kind of put that out there. And obviously we have our ending or exiting code here where we check the brackets, make sure we don't have a bracket mismatch. Also, we want to expect our ending bracket. So there's going to be a ton of code blocks that we're going to be processing, and it's going to have this exact same logic. So I'm not really going to go over that. Like, I'm going to glance over it every time when we process the function or when I'm showing you how to process it. But for the most part, I'm not really going to explain it from here on out because it's literally just copy paste. So once we do all the initial setup, then of course you want to process your module declaration. Now, this is important. Even though like this is basically going to be a copy paste from the class declaration, there's going to be different errors for every single block. So I would definitely say just kind of keep that in mind when you're thinking about the rules of the programming language. You want to make sure that you're not just copying and pasting too many things without adjusting the rules accordingly or adjusting the error messages accordingly, because sometimes it just might not make sense. So, of course, for interfaces, we don't allow module declarations. So we put that error there. Module declarations also don't allow access types. So we put that there as well. And then of course we recursively call back into an interface declaration if we have a sub interface. So interface, inner class. Like if we have some inner class here, then we can, oops, interface. So if we have like an inner class here, we can definitely process that as well. So I'm gonna go back here. So yep, that's just a recursive call back into this. Once we do that, then of course you're gonna want to add in your import declaration. That's also something we've reviewed. And yeah, that's pretty much it. So that's pretty much all the code you need for parsing an interface. Literally everything else is just individualized. So for everything else, like parsing a mutate declaration or parsing alias declarations, once we get to stuff like that, I'm going to rehash and go back into all of my block functions where it's being used and just kind of mention whether or not we have like an error message, like for instance, interfaces can't have getters and setters, amongst other things in here as well that are kind of blocked. So let's actually see the result of what I just showed today. So I'm going to go back to here and have our interface. I'm going to show you guys all the various different variants of an actual interface. So I didn't explain how to parse a method declaration, otherwise the video would have probably been too long. But at least what I can show you is we can have a interface, and we can also have a type of T, and then this one can have a base class of, I don't know, iFace. I know these names are really bad, but it doesn't matter about the names, it's just more about the formatting. So I'm going to put a breakpoint so that way we can actually see what happened here. Alright, so we're inside of our interface block. We've parsed our interface declaration successfully. So let's actually see how everything is going to look. So now if you remember, everything is done recursively. So we're going to get the printout for this interface first, and then we're going to get a printout for this interface. So if we just hit continue, we can get the actual AST that we're looking for. And let's just kind of look to see how everything looks. So we have our generic interface declaration, because this is in fact a generic interface. We have our type of T. So we have our identifier list, which denotes the identifiers or the names of the types that are going to be injected into this class. So we just have one token, which is going to be T. If we had more, we'd have multiples. And then after that, we're going to have a reference pointer, which is going to represent our base class. Now, it's not like inside of an AST called AST underscore base. You could do that if you want. I just didn't think it was necessary, so I just kind of left it like this. So now if we look at our block, after we processed our reference pointer of iFace, we have our block here, which contains another subclass. So we have our AST block with our tokens. We have our AST interface declaration, which is our sub interface, as you can see here. Then that has a block, and that has its tokens with no ASTs. So everything is working as expected. So that's it for today's video. If you guys would love to support the channel, definitely head over to my GitHub repository at github.com/androidevcd/sharp. Definitely watch, start, and fork the repository. That gives this language a ton of more visibility and lets other developers know the language exists. Also, if you guys would love to kind of keep up to date on what's going on with the language or new things that I'm adding, definitely head over to the remastered branch. This is where I do my typical day-to-day development, as well as the branch that I'm working in while I'm doing this YouTube series. So you can check out the doc folder, and that's going to contain a bunch of helpful documents, two of which are really cool. One called changelist.md. That's going to hold everything that I've already done to the language in the past in terms of updates. And you can also check out the roadmap file as well. That's going to hold everything that I'm looking to add to the language and or stuff that I've already done. So hopefully you guys enjoyed the video. Definitely like, comment, and subscribe if you guys like what you saw and you want to see more. Until next time, I'll see you guys later.